So one last look at Bezier function, and we'll do B-Spline motion. So we're going to take the Bezier motion that we already have, and we're kind of going to expand on that and build combined Bezier motions called the B-Spline. So rather than having to manually make each Bezier curve on its own and then decide when we're going to move along each one, we're simply going to set up a vector or a list of control points. Then we're going to set up a B-Spline class that will take those control points and build the corresponding Bezier functions or Bezier motions, load them up in a list, and whenever we ask for the current position in the B-Spline, it will find the current position in the correct Bezier. So let's just look at how this is. Let's, to begin with, see how our program is. We have this weird shiny moon rock here, and it's moving along a Bezier function, just as we did when we built the base Bezier motion function here. I've changed that a little bit when we're doing the Bezier patch, in that I have a separate Bezier class here which allows for the functions themselves, but no change in how we use it. So what I'm going to do is go into motion here, do a new motion and new class called B-Spline Motion. And then I'm basically going to steal the Bezier motion here a little bit. Let's just start with that, although we're going to change most of it. So B-Spline motion, we're not going to take a fixed number of control points. Oops. Instead, we'll say we take some kind of list or some kind of collection of points, call them control points. Then we have some start time and we have some end time. So also here we're not going to have these points, but instead we're going to make a list of Bezier motion let's just call it motions. So the way we're going to run through this and decide which motion we do, we can use that in many ways, also to link together different motions in a separate kind of combined motion class. What's wrong now? Okay, like so. Okay, so start time and end time, but we're going to use these control points here to build separate Bezier motions. And then when we go through this, we're going to do something a little bit different here. So this is still going to be like this, except we're going to have to say this is going to be motions dot get first motion dot okay, maybe we should we'll do this differently. Let's have a p start and a p end. The other one is just a little bit too weird. So we'll go in here and say point 3D start, point 3D start here, p-end, and since we get these control points here, we can simply say start equals control points get 0 and p-end equals control points dot, we can just say get points dot size. One fix this later on, but for now at least we have this. We have where we start and where we end, so that's where we'll be at the beginning and the end. Okay, so the main thing here is to say motions equals a new array list of Bezier motion, and then we're somehow going to add to this. So what we do with the control points is our first motion, so we'll say Bezier motion equals new Bezier motion, and our first motion will simply be motions.get 0. Will simply be made from the first 4 control points of the B-spline or the control point set. 1, 2, 3. Start time will be start time. End time will actually not be end time, but let's see what's wrong here. No, obviously not motions yet. Control points get 0, 1, 2, 3. Okay. We need to begin with here is to have some kind of increment. So we have the start time and we have the end time. We need to decide the start and end time for each motion inside this. So we have to decide, we have to calculate how many Bezier motions we'll have. So int motion count equals control points dot size divided by 2, because we take 2 and 2 control points together for each curve, except for the first one we take the first 4, so this will be minus 1. So we split them in half, divide by 2, and then take 1 off that. So that'll be the number of motions that we're going to have in the end. And we can say float time per motion equals end time minus start time divided by float of motion count. So here we have time per motion. Thus we'll have here start time and start time plus time per motion. So here we have, do it like this. So this should give us our first motion in the B-spline curve. First 4 control points here. We should obviously basically check and say if motions.size is less than 4. And we can simply return here, so we don't have to do anything else. In that case, motions simply be null. But yeah, other than that, we have the first motion here. After that, we need to make a for loop here. So for int equals, we start at 1. Since we've already made one, I is less than motion count, which we've already calculated, and I++. So for each motion, we're going to take 2 points out of the control point list, and in addition to those, we're going to calculate 2. So we're going to calculate the first 2 based on points that we have here. So we kind of need to build 2 points here and say point 3D, and we'll just call them P3, which equals this point, and P4. So it's kind of our way to reference the previous third and fourth point. So for each motion, we can say, and we'll add P1 and P2 here as well. Point 3D P1. Okay, we can just as well do it this way then. Let's say we can begin by simply doing this. So this is 0, this is 1. We can take this above this, and then we can just say this is going to be P1, P2, P3, P4. And then we build this here. So from then on, we're going to say P1 equals P4. So the next curve's first point is going to be the previous curve's last point. P2 in this curve is going to equal P1 plus a vector vector 3D dot difference, which is the difference between the previous P4 and the previous P3. So we're going to take the vector between the last 2 points in the previous curve. We're going to add that to the first point in this curve. We can even call this just P4. And that's going to be our P. Okay, so P4 is adding, do we not have a sum? Point 3D dot, or dot, okay, so add actually adds this vector to it, that's okay. Simply say P1 equals P4, P2 equals P1, and then we say P2, so we add this vector to that. Now we haven't touched P4 and P3, but now we need to get those, and we say P3 equals control points dot get, and these will be, since we're going through the motion count, it'll be I times 2, except I plus 1. So the first time we go in here, we want points number, we already have 0, 1, 2, and 3. We want point number 4 and point number 5. So this will be 1 plus 1 times 2 gives us 4. And then P4 equals control points this whole thing plus 1 again. So 4 and 5, when we have I equals 1. 4 and 5, when we have I equals 2, we'll get 3 times 2, 6 and 7, and so on and so forth. Okay, so this should fit nicely. You can also do the increment differently in order to not have this as complex, but no matter. Okay, so now we've built our P1, P2, P3, and P4 for the next curve. And then we can say motion equals, do the same thing here, except start time will be start time plus time per motion times I. Here we'll have start time plus time per motion times I plus 1. You can see that's the same thing here, because I is 0 here, so that's just start time, and this is start time plus time per motion 1. So this works either way around. So here we have, yes, okay. And what we need to do obviously here as well is motions dot add motion, and we do the same thing here. So we add that motion to our list of motions, and we have the start time and we have the end time. So the idea here, if we go once again into OneNote, erase what we already have here. The idea here is that we have a control point, control point, control point, control point. These control points, our first curve will use this, 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 and this. These 4 control points. The second curve will take this control point as its first point, take the difference between these, and add it to here. So this will be the second control point, this will be the third, and this will be the fourth. So we'll have a Bezier function looking something like this here. First one will look something like this, and then on and on. If the next 2 points are here and here, we'll take this point as the first point, the difference between these, sending us somewhere in here, as the second point, and then this is the third and this is the fourth, giving us a curve looking something like this. We've looked at B-splines before in the lecture, so you can just refer to that if this is unclear now. So now we've basically built up a vector of motions. So in this case, they're all Bezier motions and they're all linked through being the same B-spline. But it's interesting to think about this as well as just linking any motions together. So we can do that as well, just link together motions that have, each one has an end time where the next one has a start time. And we can use the code that we're going to write now to sort of put together functionality that will basically grab the correct motion at each time and poll that for what position should be along that at this point in time. What I was going to do here though was take P start here, and right here I'm going to say P start simply equals P1, and then P end equals P4 after we've gone through all of this, and we'll be left with a P4 that was simply the last point that we got off of the control point list. So we can say P end equals P4 in the end. Okay. So the idea here is that we're simply going to say for Bezier motion in motions, say if current time is bigger than motion dot start time, and current time, we could actually do it the other way around, say if motion dot start time is less than current time, and current time is less than motion dot end time. Is there a get for this? Just make it public if it's not already. We're going to do return motion dot get current position. Okay, won't return that. Say motion dot get current position, current time, and out position here, and then we can break or return or whatever. So we break this for loop here and exit this function. So we basically run through each of them, and when we find the one where current time is between start time and end time, then that's the one we should use right now. So now I'm going to go into the game class, and we're going to just make a little bit of a change here. Where are we setting the motion? Let's just take this here down below where we make the Bezier patch. So I'm gonna take this out here and say, instead I'm gonna say motion. Here isn't a Bezier motion, but a B-Spline motion. B-Spline motion. Say motion equals new B-Spline motion, and I'm actually going to put control points in there, and then just the same start time and end time. Let's see what happens just to put something in there. Okay, let's debug this then, just see where it crashes exactly. Where's the stack here? Don't I have the debug view here? Oh, doesn't help a lot. Stop this then and try it again. Okay. So let's debug it then in that case. Stop. This B-Spline motion. So let's step through this. Okay, motions. Not motion size, control point size. Okay, cool. Stop. Did go all over the place. Okay, let's make this a little bit slower now. So okay, let's start at just after 1 second. let's say it takes like almost 20 seconds to finish this. And let's get into position here and see where it's moving. It's moving along these control points there, moving towards them. It should move through every other one, but towards the other ones. Okay. So let's just make a separate set of control points for this. Let's say we just have control points be a new. Let's just take parts of them out. Leave a few. Just leave in the corner points. This one. This one. These ones. These ones. Let's see what happens now. It should just be a single Bezier motion now, starting at one of the corners, going towards another one of the corners. Down towards the other corner and ending exactly at one of the corners. Okay. If we take that and just add a couple of points, like way high up there, which will end at. Here, goes through the corner where it ended up previously, and out to there. 2, 3, 4. Does not end up. So that point in between here is a pretty weird transition from here to here. Let's just make it closer to being right there in between. It always has to take the simply because this is the last point here, the one before it. You can put that sort of on the other side here, something like this. 4 and 8 here. Make this a little bit smoother. Either way, the functionality is ready there, so just experiment with the control points and everything will snap into nice motion in the end.